this lesson we're going to take a look at the decision branching statement, the if-else statement. Now, the if-else, or decision branching, gives us the ability to change the direction of the flow of control of the program, of the algorithm. Let's take a little review. So far what we've seen is that we have input and we have output, and we can remember information and we can modify information. The other two really big capabilities that we need to be able to compute anything are decision branching and looping, that is to repeat something. So let's take a look at our if-else statement. The syntax is as follows. If expression, closed in parentheses, statement 1, else statement 2. Now in the coming lectures I'm going to give the syntax of different constructs in the same general format, and what I'm going to say about expressions and statements and keywords is going to hold through the other lessons. So let me go through this. The keywords or reserved words here are if and else. And remember, all reserved words are always lowercase. The expression here must be contained within parentheses. Even if you were to negate that logically, for instance, if you wanted to say, well, if not this, then you have to put parentheses around that. So what is expression? It's a valid C++ expression that evaluates to true or false or a numeric value. Again, remember, 0 is synonymous with false, and anything but 0 is true. And what are statements? Statement 1 and statement 2. They are individually either a single simple C++ statement with the required semicolon, or they are a compound statement. So what is a compound statement? Well, rather than just a single statement, you might want to execute several statements. So you create a compound statement by opening a set of curly braces and having multiple statements. Notice that I've indented, and in fact you see statement 1 and statement 2 are indented under the if and else clauses. You'll want to do that to format your code to show how things are flowing. So how does this thing work? Well, it's very simple, of course. If expression comes out to be true, then statement 1 is going to be executed. And the else is ignored. And then control passes down to anything down here, whatever statements follow the if-else. If, on the other hand, expression is false, then statement 2 is executed and statement 1 is ignored. It's really pretty simple. Okay, I want to give you a warning to begin with. This semicolon right here, if you put a semicolon there, what happens is that terminates or ends the if statement. The compiler sees if, then some expression, and an empty or non-statement. It will execute this non-statement, which means it does nothing, and then it's done. Okay, so this cout, it's hot outside, in this case will always be executed. The curly braces here are completely superfluous, and the indentation is misleading. It would be the next logical statement after that if. Now there's something I failed to say that might make this clearer. The else is optional. You do not have to have an else statement. You can have just an if. So that's what the case is here. Okay, example 1. If for cout hello. How is this going to be executed? Well, for is an expression. It evaluates to either true or false or a number, and in this case a number that's non-zero. If it's non-zero, then it's true. Okay, so if true, then cout hello, which means what? Cout statement is going to get executed because that's true. It is always true. And so this is actually kind of a foolish statement because for is never going to change. There's no real decision to make. I might as well have just said cout hello. On the other hand, if I say if 0 cout hello, well, 0 is what? That's synonymous with false, and the cout statement will never get executed. Let's go on to a realistic example. Let's suppose that we prompt for the radius of a circle. And we're going to read the value into a variable called radius. What we're going to do is calculate the area of a circle with that radius. Well, I want to weed out bad input. So suppose that somebody enters 0 or -6 or something like that. We don't want to calculate an area. One of the things that we can do is this. We say if radius is less than or equal to 0, then we have a compound statement. I'm going to output an error. No circle has non-positive radius. Then I'm going to execute the exit function. Now you don't know what functions are at this point, except for main, but suffice it to say at this point that the execution of this statement will terminate the run of the program. It does it gracefully, and I'll explain this in a slide later on, but it just jumps out of the program, terminates everything. The rest of the program is not executed. On the other hand, if radius is positive, if somebody enters 4, then all of this stuff here is not executed. Control passes down to this statement where it calculates the area, which is assigned pi times radius times radius. Notice that pi is all uppercase, so it's taken for granted that that's been declared as a constant and given a value of 3.14159. Then we see out the information and we see out exiting. Now, is this a good program? Well, it's not really. You certainly want to give somebody another chance to enter a more reasonable radius, and we'll be able to do that eventually. Still, even if they do give you an erroneous value, you'd certainly like to at least finish the program and to output the goodbye message here. So let's revisit this. Let's look at a different version of this piece of code. Again, we're going to prompt for and read in the radius. Okay, but now our conditions are going to be a little bit different. If the radius is less than or equal to 0, I'm simply going to output an error message, and then I skip the else. So all of this code here is skipped, and I come down to the output statement ending this example, and I can gracefully end the program with the return 0. On the other hand, if a radius value that is positive is entered, then this is false. The condition that the radius is less than or equal to 0 is false, so this is not executed, and control passes down to the else, where I have a compound statement where I'm going to calculate the area and I'm going to output it. Then control passes out of the if-else and hits the cout statement. I want to say something about the use of tabs. Tabs are a real problem. You really should avoid using the tab character when you are editing your files. When you indent, and you want to indent when the control of the program enters a new scope, so to speak, indent 2 spaces and be consistent. Not 1, not 3, not 4, and 5 is right out. Don't tab. Use 2 spaces. The reason is that on some editors, a tab character can be 2 spaces or 5 spaces. In another editor, it'll be 1 space or 3 spaces. So the format comes out really ugly. Besides the fact that when we print assignments, it can get really distorted also. So you want to be consistent with your spacing and your formatting. If you look at this block of code, it's just horrible to try to follow what's going on. If you consider that to be the line of execution, so to speak, I can't quite tell what's going on here. The closing curly brace, of course, shouldn't be there. It should be over here. Incidentally, I might point out that you'll see some authors start their curly braces over here instead of here. Please don't do that. That's a standard that we do not live by. Let's take a look at another example. This is what I call an E-sieve, so to speak. I'm going to create a sequence of constants. I've got 3 of them here, and I didn't include the rest just because of space. What I'm doing is I'm going to create a block of code that I can drop an average into and have it assign a grade. So I'm going to have a constant for max A, min B average, min C, etc. I'm going to prompt for the average and read it into a variable called av. I'm then going to jump into an if-else statement. Now, the expression for the if, that is the condition, is, to start with, if av is greater than max a, it's greater than 100, then I output an error message. Control then would pass out to the end down here. It would skip everything under the else. If that's not the case, if that's false, then it falls into the else. And I hit this next if statement right here. So what do I know so far at this point? I know that the av is what? It's less than or equal to 100. So I'm going to ask the question, is it greater than or equal to min a? And if it is, it's greater than or equal to 90. That means I'm going to assign the grade of a to grade. If it's not, then av has to be less than 90. So I'm going to ask the question, is it bigger than or equal to min b, which is 80? If so, then I'm going to assign a b. If not, then av has to be what? Well, if it's not greater than or equal to min b, which is 80, it has to be less than 80. Right? So I'll ask the question, is it greater than or equal to min c? If so, then I'll assign c to grade. And since I've gotten tired of this, I'm just going to give everybody else an F. The problem with this structure, this is perfectly good programming, but the difficulty is that because of the indentation, everything is kind of migrating right, and you end up losing space. A perfectly acceptable way to rewrite this is as follows. I'm going to write it as if av greater than max a, do that. Else if, else if, else if, else if, else if, else, etc. Now I want to make sure you understand something else here. You have if, some expression, and a statement. Else, and another statement. A common mistake made by people first learning programming is they'll try to put some sort of expression here, say not expression. But this is totally unnecessary. If you think about this, it says if expression, then I'm going to do this. Otherwise, I'm going to do that. I don't need to say anything here, and in fact, it won't compile. So don't make that mistake. Okay, let me explain the exit function versus the return 0. In both cases, when these expressions are evaluated, you're sending a value, an integer, back to the operating system. Those values can be used in the future. We will not use them in this course, but can be used to signal different situations. When 0 goes back to the operating system, that can be interpreted as the program ran to completion. It hit the very last statement, return 0. That says everything went fine in the program. When you hit an exit, you send a numeric value, say 3, back to the operating system. What that means is that some sort of an error occurred, like the one a minute ago. And the value can be mapped to the error conditions, and then some action can be taken. When an exit function is executed, all variables are deallocated, everything is shut down gracefully, but the program is not completed. It does not run to completion. So the exit function is only used under the conditions that something bad has happened. I introduce it here now because we don't have the standard way of handling exceptions, handling difficulties in a program. That's called exception handling. It's a rather advanced topic, and of course we can't go over it here now. So end your main program with a return 0. Use the exit only when it's an indication of some failed state in the program. That's the end of this session.